y's, we have 2x, we have 5x and 3x, 2y and 4y, 0z, 2z, 4 and 6. So let's get rid of the y's. So what do we need to multiply each equation by to be able to do that?
2 for the top equation.
Right.
For the bottom.
Right. So I'm writing under my notes, eliminating the y. So we are multiplying the top equation by 2.
And the bottom one goes by 4, right?
No, the bottom one we don't need to do anything because we already have a 4y. So it's good. We don't have to change anything. So what do our new equations look like? So what does the 2 times the top equation become?
10x
Yep.
4y plus 0z equals 8.
Equals 8. Okay, right. Yes. Okay, so now I'm going to make this a new step. I'm going to say it's going to be subtract equations 1 and 2. So, because we have 10x plus 4y plus 0z equals 8 minus 3x plus 4y plus 2z equals 6. And what does that give us?
2x minus 0y minus 2z equals 2.
Wait, so 10x minus 3x.
Oh, 7x, I mean.
7x. Our y's drop out. Poof, gone. 0z minus 2z is minus 2z. Equals 8 minus 6 is 2. Okay. So now we have, and under my notes I'm going to put, now we have our first new equation with 2 variables. Okay, so now I'm going to make a new step. So making a new box. Okay, so we've done the first one. So now what do we need to do?
You started the new equation and the third equation.
Oh, so actually we need to do the second equation then the third equation. We don't use the new equation until after this next step. So now we take equations, so we subtract equations 2 and 3. Now we subtract. Oh, sorry, before we say subtract, we need to eliminate the y. So I'm going to write it as eliminate the y by subtracting equations 2 and 3. Okay, so equation 2, Robert, you getting this down, sir?
Yeah.
Okay, good. Okay, so what we have is 3x plus 4y plus 2z equals 6. That's equation 2. And then we have our third equation is 7x plus 3y plus 4z equals 29. All right, so we have to eliminate the y. That's the rule. So what are we going to do? What are we going to do that? We have a 4y and a 3y. What do we need to multiply each one by to get rid of the y?
Multiply the first one by 3 and the second one by 4.
Correct. So we're going to say we're going to multiply second equation by 3 and third by 4 to eliminate the y. Okay, so what do we get? What's our first equation when we multiply the whole thing by 3?
9x plus 12y plus 6z equals 18.
Correct. 9x plus 12y plus 6z equals 18. How about our second equation? When we multiply that by 4, what do we get?
28x plus 12y plus 16z equals 116.
Plus 16z equals 116.
Yep.
Nice job. All right. Okay, and so now we have a positive 12y and a positive 12y. So we have to subtract these guys. So what is, so we have to subtract, there's a little tiny minus sign in there. So what is 9x minus 8x? Yep, x. 12y minus 12y,
Get rid of the y.
gone. 6 minus 16,
Negative 10.
yep, negative 10z equals 18 minus 116. 18 minus 116.
Negative 92.
98.
98.
Okay, so now we have 7x minus 2z equals 2, and x minus 10z equals 98. Okay, I have to switch whiteboards because I'm running out of room. I have to write that down. 7x minus 2z equals 2, and x minus 10z equals negative 98. Okay, just a second. I'm going to get a new whiteboard.
Just x minus 10z?
Yeah.
Okay, so now we have 7. Oops, I got to write. Minus 2z equals 2, and x minus 10z equals negative 98. Okay, yeah, 19. All right, there's my pen. I lost my pen. Negative 19.
Yeah.
That sounds way better. That was too easy. All right, when I carried it over to the new one, I didn't write it down properly. Negative, oops. So now we have 7x minus 2z equals 2, and negative 19x minus 10z equals 98. Everybody good with that?
Yep.
All right. Well, I am using one of Quinn's crayons.
Wait, how did we get that from the two?
Those were our two new equations. Those were our two. So I'm gonna,
Yeah.
so I'm gonna write our notes. So these are, we need to subtract.
Wait, negative 19x minus 0y.
10, yeah, minus 10z equals 98. And we left the y's out because both equations dropped out of the y, so we don't really need that placeholder. So we need to subtract or add the two new equations to eliminate one of the variables. Do we want to eliminate z or x?
I mean Z.
Well, we have a 19 and a, so a z, yes, I think we have a 19, negative 19 and a 7, so that's going to be harder to find lowest common multiple. But I think 10 and 2 are easier. So we're going to eliminate the z. Okay, so what that means is, what do we need to multiply our first equation by? We're going to multiply the first one by 5, which will give us that 10. So what does that become? 5 times 7x?
35.
35x. 5 times negative 2z is a negative 10z equals 5 times 2? 10. Okay, so from there, we now need to subtract, like this. I'm going to do another step. So we need to subtract the two equations to eliminate our z. Okay, so we get 35x minus 10z equals 10 minus 19x minus 10z equals negative 98. So we actually need to subtract this. So we need to make sure we take into account subtraction of each term, which will change our signs. So 35x minus negative 19. So we basically get 35x plus 19. And then what does that give us?
212.
Oh, it's
No, 214.
oh, 35 plus 19, not multiplied. So 35 plus 19 will give us 54x. Negative 10z plus 10z.
0.
Go on. 10 plus 98, or 10 minus a minus, which is plus. So what's 10 plus 98? 108. Okay. So now we have 54x equals 108. X equals, how many times does 54 go into 108?
2.
2. So we know our x value equals 2. So we have x equals 2. Okay. So now we need to go back and look for an equation that only has two variables, one that has an x and another one, and then we can solve for our other equation, or our other variable. So the two new equations that we have, remember, we're like 7x minus 2z equals 2, and negative 19x minus 10z equals 98. So basically, we have that x now, like we did in the other equation, to dump back into our, we can dump that back into this equation and solve for our z. Does everybody understand that? I think this is where it starts to get tricky. So we're gonna take, so I'm back to the very top of the whiteboard. So on the, what I'm writing is we're gonna do 7x minus 2z equals 2, and we're gonna substitute in our x value, because that's what we solved for, right? And our x value equals 2. Yes. So now we have 7 times 2 minus 2z equals 2. When we solve, we get 14 minus 2z equals 2. We have to subtract that 14 over, so we get negative 2z equals negative 12.
Yes.
Okay. So z equals 6. All right. So now we have two values. We know x equals 2 and z equals 6. We can then take these two values and put them back into our original equations. Any one. Let's look at which one will be the easiest. Let's put it in, so we have z and x. So we have to put it in, well, we have x, so we can put it in our first equation and not even deal with the z, because we have 5x plus 2y equals 4. And we're going to solve for y. Do we have enough information to solve for y?
Yes.
We do. So let's put in our x value. 5 times 2 plus 2y equals 4. We have 10 plus 2y equals 4. 2y equals 4 minus 10 is negative 6. So y equals negative 3.
You could have put that in any equation though, right?
Oh, absolutely. I put it in that one so we didn't have to substitute in the z as well. But you can put the z and the x in for any of them. So our solutions are, we have 2 comma negative 3 comma 6 as where these three equations intersect on the graph. So the x component is 2, so that's your horizontal. Your y component is 6. And your z, the one that comes and crashes through these guys, is at 6. So that is your solution to that problem.